Good morning, all. Myself, Sruthi P, Assistant Professor, Department of Electronics and Communication Engineering, Vedavyasa Institute of Technology. Today's my topic is optical fiber communication. So, optical communication utilizes the principle of total internal reflection. When the incident angle of light satisfies certain conditions, light can form total internal reflection in the optical fiber, therefore achieving the purpose of long distance communication. That means communication via optical fiber involves the transmission of information such as digital data or voice through a network of thin glass or plastic fibers that use light to carry the signal. The process begins with an electrical signal which is converted into light using a laser or light emitting diode. So it's the evolution of fiber optic system involved first generation, second generation, etc. The first generation uses a gallium arsenide semiconductor laser. Then second generation include bit rate is 100 MB per second. Then third generation bit rate is 10 GB per second. Fourth generation uses WDM technique. Then coming to fifth generation, it uses Raman amplification technique and optical solutions. The advantages of optical fiber systems are much higher bandwidth. That means thousands of channels can be multiplexed together over one strand of fiber. That's the main advantages of optical fiber system. Then another one is immunity to noise. That is immune to electromagnetic interference. Then safety, high security. Then fiber optic advantages include greater capacity, smaller size and lighter weight, lower attenuation, immunity to environmental interference, highly secure due to tap difficulty and lack of signal radiation. The disadvantages of optical fiber or disadvantages include the cost of interfacing equipment necessary to convert electrical signal to optical signal. Splicing fiber optic cable is also more difficult. Then areas of application include optical fiber communication used mainly in telecommunications, local area networks, cable TVs, CCTV, optical fiber sensors. Then what is ray optics? Refraction and total internal reflection. Optical fibers work on the principle of total internal reflection. That means the angle of refraction at the interface between two media is governed by Snell's law. That Snell's law is indicated as N1 sin phi 1 is equal to N2 sin phi 2. Where N1 is refractive index of core and N2 is refractive index of cladding. That means angle of total internal reflection occurs when angle of incidence is greater than critical angle. Then total internal reflection will take place. Then what is numerical aperture? That is the light gathering and acceptance capability of the fiber. That means the angle of acceptance is twice that given by the numerical aperture. Then optical fiber is it is a cylindrical transparent waveguide that convert electromagnetic waves at optical frequencies. It include in optical fiber, it's mainly include a core and a cladding. Core carries light made up of glass. Refractive index is indicated as N1. Cladding in refractive index is indicated as N2. That means cladding means it surrounds core and refractive index is N2. Then avoid scattering loss, provide mechanical strength. The index of refraction of the cladding is less than that of the core. A light emitting diode or laser diode can be used for the source. And advantages of optical fiber include greater bandwidth, lower loss, immunity to crosstalk, no electrical hazard. Then optical fiber modes and configuration. The optical fiber is a dielectric waveguide that operates at optical frequency. The propagation of light along a waveguide can be described in terms of a set of guided electromagnetic waves called the modes. These guided modes are referred to as bound or trapped modes. Then modes of configuration include multi-mode and single mode. In multi-mode, there are two types, step index and graded index fibers. Then what is single mode fiber? It's in single mode fiber, core size is small. That means typical core size is 2 to 15 micrometer. Only one mode can propagate through this type of cables. So single mode fiber is also known as fundamental or mono mode fiber. The next case is multi-mode step index fiber. Then it is core size is small. Typical core size are 50 to 1000 micrometer. Then multiple modes can propagate through this multi-mode step index fibers. Then another type is graded index multi-mode fiber. Core refractive index diminishes gradually from center axis out towards the cladding. The core size is varying from 50 to 100 micrometer. The light ray is propagated through the refraction. The light ray enters the fiber at many different angles. Then it minimizes the dispersion loss. Then signal degradation in the optical fiber include signal distortion may occur through dispersion and another through attenuation. Attenuation include absorption such as scattering losses, radiating losses, etc. Then dispersion distorts both pulse and analog modulation signals. In a pulse modulation system, this causes the received pulse to be spread out over a long period. It is noted that actually no power is lost to dispersion. The spreading effect reduces the peak power. So the light emitting diode is the source. A light emitting diode is a semiconductor device that emits light when an electric current is flowing through it. When current passes through an LED, the electrons recombine with the holes emitting light in the process. LEDs allow the current to flow in the forward direction and block the current in the reverse direction. The LED symbol is the standard symbol for a diode with the addition of two small arrows denoting the emission of light. The advantages of LED include it consumes less power, the emitted light is monochromatic, inexpensive, reliable and easy to handle. Then application of LEDs include LAN and WAN used for TV backlighting, used in displays, etc. Then laser is another source. Laser means light amplification by stimulated emission of radiation. It is widely used optical source for optical communication. That is the second one, laser. It is widely used for optical source for optical communication. It's working on the principle of stimulated emission. It has coherent light. Then laser diode suffers from three problems when used as optical source. It includes temperature sensitivity, back reflection, etc. Then photodetectors. Optical detectors convert optical signal to electrical signal. Photodetector is the fundamental element of optical receiver followed by amplifiers and signal conditioning circuitry. There are several photodetectors types, that means photodiodes, phototransistors, photon multipliers, etc. Requirement of photodetectors are compatible physical dimension, high response or selective at a desired wavelength, low noise, high bandwidth, etc. Then principle of photodetector is working principle is optical absorption.